Hello everyone and welcome back to another video. Today we're looking at more pre-calc problems. With this problem we are asked to match one of these graphs with one of these exponents in this bank here if we were to plug in these fractions into the function x to the a. So if you remember from the last video, first we determined whether this fraction here would make the function even or odd. And then we had to look at whether the fraction would be less than or greater than 1. That's going to tell us what the graph is going to look like. So for this first one, well actually, what I like to do first is go ahead and mark all the even functions. And again, all the even functions are symmetrical across the y. So this would be even, this one would be even, and this one here looks to be even. Next, mark all your odds. This one's odd, this one is odd, and this one here is odd. And this one's neither. Okay, so just based on that, you should be able to get a much clearer idea of how to do this problem. So remember, for an even function, the numerator is going to be even, and there are only 3 even graphs, so that means there's going to be 3 even fractions up here, or at least the numerator is going to be even. So we have 8/3, 4/7, and 2/3, and so the next thing we have to look at is whether these fractions are greater than or less than 1. So if the fraction is greater than 1, then the graph is going to be concave away from the x-axis, so it's going to look like that. So this one matches that description, so this answer here is 8/3. For 4/7, this one you can see is less than 1, so it's going to look more like this graph, where it's concave away from the x-axis. So this one here is 4/7. And then finally we have a negative number, which if we were to write that out, this would be x to the negative 2/3, which rewritten would be x 1 over x to the 2/3. And the so what does this mean? Well, if you plug in a 0 for x, then this would make this function undefined. So the even function here looks like there's an asymptote here at x equals 0. It's a bit sloppy, but so this matches the description. So we'll have 2/3 here, or negative 2/3 there. Okay, so now that we know that 8/3, 4/7, and where's the last one here? Negative 2/3. These are all gone. So now we're left with these 6. So to look for an odd function, both the numerator and the denominator have to be odd. So we have 5/3 here, where 5 is odd, 3 is odd. And if you look at 5/3, it looks like this is greater than 1. So again, it's going to look like this graph, where the line is concave away from the x-axis. So we're going to assume that this is 5/3. And then the next one is 1/3, where that's less than 1. And so that's going to be concave away from the x-axis. So we're going to do 1/3 here. And then finally we are left with negative 1/3. So this one's going to be odd, which is down here, and it's less than 1. Well, this one's actually another one of those inverse functions. So this would be written as x to the negative 1/3, which is actually 1 over x to the 1/3. So it is going to be this function here. So finally we're left with the neither functions. That means that we have an even number in the denominator. So for 1/4, we can see that it is, first of all, it has an even denominator, and it's less than 1, which again means that the graph will be concave away from the x-axis. So this here would be 1/4. And then we have 5 over 2, where it's going concave away from the x-axis. So this would be 5 over 2. And then finally we're left with negative 1/2. So this one is a negative, again, just like these two. So that means that the function can never be 0. So we have an infinite discontinuity here where this function will never be 0. So it's safe to say that this one is negative 1/2. So with these problems, practice makes perfect. Just recognize whether the graph is even or odd, and then look at whether the fraction is greater than or less than 1 to determine if it's concave up, or sorry, concave away from the x-axis or concave towards the x-axis. Okay, in this problem, we are asked to factor and solve each trinomial. It's just a big word, but basically we're doing some foiling, so I hope you remember that from Algebra 2. So I'll do one of these for you. These should be pretty straightforward. This is more of a recap from Algebra 2. So I'll do what I think is the hardest one for you, and then I'll leave the rest for you to solve. So starting, let's do this one. So we have g squared plus 11g plus 24. So we basically have to find two numbers that will multiply to this number to 24 and will add up to 11. So to do that, you can list out the greatest common factors. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Now we have to find a combination of these that will add up to 11. So if we look here, we can see that 3 times 8 equals 24, but 3 plus 8 will also equal 11. So we can FOIL this out, and since they're all positive, since these two terms are positive, we can leave them as x plus 3, x plus 8. And when you set them to 0, just like they did up here, we will get that x will equal negative 3 or negative 8. When you see ones like this, the first thing you want to do is move this 48 over so that you can make it set the whole thing equal to 0. So we'll have j squared plus 13j minus 48 equals 0. So we have to find two numbers that will multiply to negative 48, but will add to positive 13. So how do we do that? We can factor out this 48, or find the greatest common factors. So you can do it by starting off with the smallest, which would be 1 times 48 will give you 48, or 2 times 24 will give you 48, 3 times 16 will give you 48, 4 times 12 will give you 48, and we can keep going, but if we can see here, we have a 16 and a 3, which multiply to negative 48 if this one of these two numbers was negative. But the next thing that can help you is we're adding to a positive 13. So if we had a positive 16 and a negative 3, that would give us positive 13 because we would have 16 minus 3. So we can factor this out to x plus 16 and x minus 3 to be 0. And finally, we have to solve these out. So x plus 16 equals 0, and then x minus 3 equals 0. And if we solve that, then x would be negative 16, or x would be positive 3. And that would be your answer, these two x values here. So this next one is pretty similar. We have, first we're going to move this 35 over. So we have k squared minus 2k minus 35 equals 0. So again, we're finding the greatest common factors that will multiply to negative 35, but add up to negative 2. So again, you can list the common factors. This would be 1 times 35, or we have 5 times 7. So this one doesn't have that many common factors, but easy enough. We have 7 and 5 to, so if we had negative 7 and we add positive 5, we would get negative 2. So our factoring here would be x minus 7 and then x plus 5. And when you set these equal to 0, we'll have x equals positive 7 and x equals negative 5. So the rest of these are exactly like these, except there's one less step. This one here might trip you up, but if you remember the perfect squares, this just factors out to f plus 4 and f minus 4. But the rest are all the same. So, if you need any help with any of these, just leave a comment and I'll try and solve it out in the comment section. But they all work more or less like this. Just find the greatest common factor and see which pair add up to this middle number.